going to start, what I'm going to do, I'm going to finish up 7.1, and I'm recording the lecture today. And the reason is that it's voting and everything. So if you need to head out and vote real quick, do that. I'll be recording the lecture, and the idea there is that if you need to go now to vote, go vote. I'll post the lecture online and send out the link to everybody, so you'll have that. So I'm going to get started. What we're going to do, we're going to finish section 7.1. So we had this example. We were talking about the law of sines. So what we have a triangle like this. The law of sines says we take side A over the side of angle A. So we're using the capital letters to label these corners. These corners are angles. Now usually you put the letter on the inside, but for the law of sines, we're putting them on the outside, on the corner. So A over sine A, B over sine B, C over sine C. So this is our law of sines. And we were looking at some ambiguous cases last time. One where we actually had a situation, there was no solution. We ended up taking the sine of an angle, we got like 1.33. And you can't have the sine of an angle be equal to 1.33. So that's a non-existent angle. So some of these, they don't always work out. Now we're going to go back to an example we started last time where we have an ambiguous case. And we have this. So in this situation, we've got a couple things to consider. Now, if you look back on page 735, so this deals with these ambiguous cases. And the one we're going to look at is the two triangles. Specifically, let H equal the height of a triangle. And this is specifically going to be B sine of angle A. Now let me draw what's going on here. And that whole side is C. Well, here's angle A. So the height, if we think about height, we have our opposite of A, and this is our hypotenuse for this right triangle. So that means sine of A is H over B. Solve for H. That's how we get that. That's where that's coming from. So we're going to consider a situation like this. A is going to be bigger than the height, but it's going to be less than side B. So let me put that like this. A is less than H. But A, I'm sorry, it's greater than H. but it's less than b. So what does that do? Well, what happens is we're going to have two possibilities for this triangle. So one possibility is going to be this. We could have a triangle like this. The other possibility, and this is a triangle we're going to need to solve as well, could be this. Now, in both of these cases, here's the height. Here's the height here. In both these cases, A is bigger than the height, or is longer than the height, but is shorter than side B. So we have to consider both of these triangles. So let's do this. All right. So where this is going to come up, as far as your calculations are going to be concerned, we know A, and we know angle capital A. So these two are known. We know B, but we don't know angle B. So known, 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 unknown. So we're going to solve for this. So we could cross multiply. 54 sine of B is 62. Sine of 40 degrees. Divide both sides by 54. And there we go. So just double check the algebra, make sure this is done correctly. Looks good so far. All right. So let's turn this into a number. Let's actually do the calculation. Let me grab my calculator real quick. There we go. Let's see. Double check, make sure my numbers look good. They do. So what we're going to get is sine of b is going to be approximately, and I'm going to use as many digits as I can. So now we're going to take the sine inverse of this. And if we do that, double check my numbers there. So they're rounding it to about 0.48. We'll do the same thing. So this will come out to, oh, not 0.48, about 48 degrees. It actually comes out to 47.56. So they're going to round to 48. Now we want to be careful a little bit with this. Let's go back and look at our two triangles. Figure C here. So the thing we want to be careful of with this, let me double check one thing here. Yeah. The thing we want to be careful with this is angle B. When we think about the two different triangles, angle B is certainly going to be different. Now, to be fair, I mean, angle C is also going to be different, but we're working with angle B right now, and certainly we have an obtuse angle here, we have an acute angle here. Now, if we think about the way our angles work, so we got a sine of B as 0.73801,504. I want to call it about 0.738. Well, there's two angles. That have a cosine of 0.738. We can have an angle here. Or down here. Now, both of these angles, remember sine and cosine. This will be cosine theta 1, sine theta 1. And this will be cosine theta 2, sine theta 2. Oh, I'm sorry, we're dealing with sine. Sorry, sine. Ooh, let me go back. Got sine. Check my numbers. So there are two angles I forgot. We're doing sine, not cosine. So we've got two angles to consider. We have theta 1. And again, remember the sine is the y coordinate for our angle. So 1, this is going to be our sine of theta 1, 0.738. We just figured out what this theta 1 is. Theta 1 is approximately 48 degrees using our sine inverse. And keep in mind with sine inverse, it's only going to give you angles from negative pi over 2 to pi over 2 to begin with. And that's just the way we set up the sine inverse. We limited it that way on purpose. But now, and that gives us this angle here. That's what we've got. But let's take a look at this. That's an obtuse angle. And it's going to be something between 180 and 90 degrees. So we're going to be talking about theta 2. So how do we figure out this angle? Well, again, we're going to go back to reference angles. This here, if we ignore the fact that it's going counterclockwise or going clockwise, this would also be in magnitude equal to theta 1. So what we're going to get is this. We call this theta prime. Theta prime is going to be theta 1, and this is as a reference angle. So to find theta 2, we take 180, or pi, and we subtract from, we're going to stick with degrees, from 180 degrees, we subtract this reference angle. And so what that's going to give us. And again, it's approximately 48. Just make sure that, yeah, we're going to stick with that. I typically with these, I recommend using as many decimals as you can, but I'm going to let you do this. And so this will give us theta 2. Theta 2 is our other version of B. So we have two measures for B. So A is going to be 40 degrees. So we have 40 degrees. For this version of B, 132 degrees. And then we have, let me make this a little bigger, crammed on here. Do this. We've got our first triangle. Here's our second. So we can call this B1 and B2 to coincide with theta 1 and theta 2. So what we're going to end up doing is we're going to be working with these two triangles. We're not going to shake one or the other. We're just going to have to work through them. So what happens when you get this sort of ambiguous, it is an ambiguous case, you're going to get two triangles where you have two different B's, and you're just going to have to work with these two separate triangles until you come up with solutions for both. So, pardon me 1 second.
Hello, checking the clocks.
Oh,
Got any that need to be set?
no, I think we're good.
Okay.
Thank you, thank you. Pardon me, a clocks man came around and was making sure all the clocks are up to date. So he made a fall back on Sunday. So anyway, this is where we're at. So again, we're going to solve these triangles. That means we want to find all the angles along the sides. And because this one's going to give us two triangles, we got to consider the big angle and the small angle. Now, we are missing one angle on one side. Well, for the angles, this isn't going to be too bad because now we've got two angles here. So for this triangle, A plus B2 plus C's got to equal 180. For 40 degrees plus 132 degrees plus C is 180. Or we'll get our 162 or 172. And we'll squeeze this in here, C, 8 degrees. So that means for this triangle, we've got 8 degrees for C, which looks like, yeah, it's a small angle. That seems reasonable. So now let's find C for this triangle. And we could also call this, say, C2. I know they do that in the text. C1 and C2. C2 and C1. So, same thing. A plus B1 plus C1 equals 180 degrees. Or 40 degrees plus 48 degrees plus C1. 180 degrees. 88 degrees plus C1 equals 180 degrees. Or C1, do some mental math, 92 degrees. And that's going to be our answer. So C1, a little bit obtuse at 92 degrees. So the last thing to do is we just need to solve for our two sides here. Now again, we're going to have two different sides. Opposite C2, side C2. Opposite C1, side C1. And again, if we can, if the problems allow us to do this, we want to try to use, for our law of sines, the angle and the side that's given to us. We will have to stick with the angle that we found for the C's, but we'll try to use angle A, side A, again, angle A, side A for our law of sines. Again, trying to avoid using things that have been rounded off. You kind of do the best you can with that. Again, I recommend using as many digits as you can, but it looks like in the text they're not quite sticking to that. So we'll just continue on. We'll go with how they're approaching it. So remember, this is A. This is B, B, A. So A sine A. And then I'm going to go with this top triangle here, C2 sine C2. Again, we'll cross multiply. And we'll actually just do it this way as well, without putting in the numbers just yet. Make this a little bigger. So this is the angle. So A sine C2 equals C2 sine A. So plugging in what we know. Well, A we know is 54. And then we found C2 for this top triangle to be 8 degrees. Then we don't know side C2. A at 40 degrees. So solving for side C2. We're going to get that. And if we hammer out the calculation, we'll hear on my calculator what I would get. $11.69, and yeah, they're rounding that to 11.7. So you'll get 11.7 is approximately side C2 for the top triangle. So now we've solved this triangle. It's all set. We have all the angles and we have all the sides. Now we got to finish this one. Now for this one, we do have all the angles. We have 2 of the sides. We just need side C1. So again, law of sines. A sine A. And then we'll have side C1, angle C1. We'll cross multiply. Plug in our numbers. Again, C1's about 92 degrees. We calculated that using a rounded angle. And then C1 was 40 degrees. So we're going to solve for side C1. Let's see if we do that. We're going to get, and let me double check here. Yeah, you get 83.9579. We're going to round it to approximately 84. So now you've solved both triangles because there's 2 possible triangles that can come out of this problem. So any questions about that? All right. The last thing to mention in this section is they have an area formula. And so basically it's going to work like this. So recall for a triangle, regardless if it's a right triangle or an oblique triangle, that the area is 1/2 base times height. Now in this case, the base is C. Now we need to come up with the height. Well, what we can do is this. Just like we were looking at the formula for height with the ambiguous cases, we're going to use the same formula here. Sine of A is H over V. So solve for H. And that's going to give us the height. So what we'll get is 1/2 C times B sine A, or 1/2 BC sine of angle A. So that's where that formula is coming from. So a quick example. Let's see here. Let's see, let me find a triangle here that's going to work. I'll use the example text. It's readily available. I don't want to try to make up a triangle that's not real. Be a little careful about that when you're doing things with triangles. So let's do this. And we're going to call this 62 degrees. So the key things we need for the area, it's 1/2 B times C times the sine of A. So we've got our triangle ABC. We've got a side, and an angle. So if we've got a setup like this, where we have a base, and then knowing that base, we've got the angle, we've got a side, we can use this. So let's go ahead. Filling in what we have, 1/2. B is 10. C is 24. Sine of 62 degrees. Hammer that into the calculator. we're going to get approximately 105.537. 111. I think in the text we rounded to 106. So that's going to be your answer. So any questions about that? So that's it for the law of sine. Well, no, it's not. That's it for the law of sines, because we're going to use the law of sines when we get to section 7.2, which we're doing right now. So what's going to happen? We're going to get the law of cosines. So let me derive. There's 3 formulas we have for the law of cosines. Let me derive one of them. So let's say we have this. And then we have little a, little b, c. Well, what we're going to do that's a little different, we're going to bring in the y-axis and an x-axis. And the corner of the triangle where we have angle A, that's going to sit at the origin. The height we're going to call y. And then where that height drops, we're going to call that x. Now, to derive this, I'm going to make this observation. The cosine of angle A and then the sine of angle A. So the cosine of A is going to be adjacent over hypotenuse, for x over b. The sine of A was going to be opposite b. So what we're going to end up doing, we're going to solve for x, we're going to solve for y. Again, I'm just following what's in the textbook. So, and this is going to be page 745. So b cosine A is x. B sine A is y. So what we're going to do is we're going to solve for this sine. Now, where we're going to use x and y is with the Pythagorean theorem. So keep these in mind. So let's take this triangle, let's extract it here. This is y. Now, the entire base of this triangle is c. This part is x. So to find this part, we take c minus x. So this will be c minus x. Now, in the textbook, what they do is they call it x minus c. You're not going to have to do that in this case. And the reason's going to be this. We're going to square this. And so when we square it, whether we have c minus x or x minus c, it's not going to matter. X minus c will be a negative number. C minus x, because c is bigger than x, well, that'll be a positive number. So when we square it, Well, this is the positive version. This is the negative version. You can think of it like this. 5 minus 2 squared equals 3 squared is 9. Likewise, 2 minus 5 squared is minus 3 squared is also equal to 9. So if you're wondering what they're doing in the textbook, that's why they're not worrying about c minus x or x minus c, though I do believe in the textbook here. Let me look. They should be going with, yeah, x minus c. So anyway. So let's square this. So using the Pythagorean theorem, this squared plus this squared equals that squared. Now y squared is just y squared. This we're going to have to FOIL. We'll get c squared minus 2xc, or 2cx, both 2cx, plus x squared. Now, this doesn't seem to be getting us anywhere. Our triangles in terms of A, B, C angles, and then A, B, C for sides, and juggling these is enough trouble. Now I got this x and y in here. Well, think back to what we did with cosine of A and sine of A. We found that B cosine A was equal to x. And then B sine of A was equal to y. So now that we have our x and y, we can substitute. So we'll get a squared is going to be b sine of a squared plus b, plus c squared plus, minus 2c. X is going to be b cosine A plus b cosine A squared. So all we're doing is making a substitution for y, substitution for x, substitution for x. So you have a squared will be b squared sine squared A plus c squared minus 2 bc cosine A plus b squared cosine square root of A. A squared. I'm going to combine, so to speak. Not really combine, but take a look at my b squareds here. B squared plus b squared cosine squared A plus c squared minus 2bc cosine A. And what we can do is factor out the b squared. So a squared would be b squared sine squared A plus cosine squared A plus c squared minus 2bc cosine A. And if you recall your Pythagorean theorem, or your Pythagorean identity, for sine squared plus cosine squared, that's equal to 1. So b squared times 1 would just be b squared. So a squared, so b squared times 1 plus c squared minus 2bc cosine a. Finally, a squared is b squared plus c squared minus 2bc cosine of a. Whew. And that's one of our law of cosines. There's 2 other formulas for this. So the other 2 are going to be this. I'll give you a second to write that down. Now, the kind of triangle we're going to solve for this, we use this formula to find side A. So we need to know side B, we need to know side C, and we need the cosine of A. So that means we need to have angle A between B and C. So for this version, what we're looking for is a triangle. See, we don't know that, but we have A, B, C. We don't know A. Oh, sorry, wrong A. We don't know A. This is A. This is side A. But we know side B, and we know side C. So if we know these 3 things, then we can find this missing side. So any questions about that? Now there's different versions of this. There's b squared equals a squared plus c squared minus 2ac cosine of b. And then c squared is a squared plus b squared minus 2ab cosine of c. So we have these 3 formulas. Now, to actually use this, so if we know a side and we know an angle and we know the other side, and the angles between the 2 sides, then what we have is a side angle side triangle. So we're going to solve a side angle side. So step 1. The first thing we're going to do is solve for the missing side using the law of cosines. So next what we're going to do is we're going to use the law of sines. Let me double check here. So we're going to use the law of sines to find one of the missing angles. Because remember, side angle side, we have only 1 angle, we're missing 2. So what we're going to do, we're going to find the side or the angle across from the shorter of the 2 sides. So that means when we look for this angle, we're not going to just find any of the two angles we feel like. What we're going to do is we're going to find the angle across from the shorter of the two sides. And I should mention these are the given sides. So we're given one angle, but we're given two sides. One's going to be usually shorter than the other. And so we're going to find the angle across from the shorter side first. So we do want to be careful here. You don't just want to jump in and just, well, okay, I'll go solve for this angle. It's got to be a particular angle. It's got to be the angle that's across from the shorter of the two sides. So if we're given something like this, so if we're given a side, got to solve for this side. The first thing we're going to do is A will be the law of cosines. That's going to be number one. Number two, we're going to look at these two sides. The angle across from it, we're going to look for using the law of sines. Now, if this was shaped a little differently, maybe we'd be looking for angle C if this was the shorter of the two sides. But in this example, it's not. So we'd solve for A and look for the shorter of the two sides. It's going to be that side. Use the law of sines to find that angle across from the shorter side. Now, the third step is then find C using the A plus B plus C is 180 degrees. So the law of cosines is not going to be used. Give me a second to write that down in your notes. It's not going to be used, as you might say, in a vacuum. It's going to be used with the law of sines. So Sims Y 7.2 is law of cosines and law of sines. We're going to need to use the law of sines to help us with problems involving the law of cosines. So let's do an example. So let's say this. Again, in SAS triangle. And let's see here, we have A is 60 degrees. B is 20. And C is 30. So let's draw a picture, see what's going on here. So C is 30, it's a longer side than B. A is going to be 60 degrees. B is 20. C is 30. Something like this. There's B, and there's C. Oh. So what we want to do first, step one, is solve for A. Use the law of cosines to find A. And if you recall the formula for A, it's A squared is B squared plus C squared minus 2BC cosine of angle A. So that means A squared is 20 squared plus 30 squared minus 2 times 20 times 30 times the cosine of 60 degrees. So 20 squared, 400. 30 squared, 900. 20 times 30, 600. Times 2 is 1200. Cosine of 60 degrees. So that's going to be, you can use your unit circle on this one. It's going to be 1/2. So A squared, 1300 minus half of 1200, 600. A squared, 700. So this means now we got to take the square root of both sides. Now, because we're dealing with a length, we're going to take the positive square root, not the negative. So A is approximately, so square root of 700. Let's see here. About 26.4575. Just let me see how they rounded this off. They're going to round it off to about 26.5. And I'll be honest, I'm kind of a fan of, again, using as many digits as you can. We'll go with that. Go with that. So that's step one. That is our first step. So in your notes, and I should have put this here, put a step one there at the beginning of that calculation. That's your step one. Now step two. We've used the law of cosines. Now we're going to go use the law of sines. Now, of the given sides, we're given B is 20 and C is 30. So the smaller of those two sides is going to be B is 20. So that being the case, we're going to solve for the angle across from the shorter side, which is going to be angle B. So that means we're going to use this. And, well, what do we use for the other side? Well, we've got C is 30, but we've got an angle C we don't know. And we don't find angle C until the third step anyway. So what we're going to do, because we need to know angle B first. So we're going to go with 60 and then 26.5. So A, which we have an approximate value for, sine of A. And again, we can't use C because we don't know it. So again, we can cross multiply. And I'm going to keep it in formula form. Sometimes this is easier. Keep it with the variables as they appear in the formula before replacing them with numbers. So B sine A. Well, B is 20. The sine of A will be the sine of 60 degrees. and that's equal to A, approximately 26.5 times the sine of B. So solving for sine B here, let me make sure I've got the 20, got the sine of B, that's good. And then we've got the sines, the 26.5, sine of 16. Should be good. So solving for sine B. And if we calculate this, we'll get 20 times the sine of 60 degrees. And again, you want to make sure your calculator is in degree mode for these calculations. So about 0.653604. 040. 78. So now we're going to take the sine inverse of this. Of about 40.8 degrees. I'm just looking at how that's been rounded. They're rounding it to about 41. So now we got sine of B, I'm sorry, angle B. So approximately 41 degrees. And you might ask, well, wait a minute. Last time you did a sine inverse on angle B, we ended up getting two triangles that split. Well, one of the things you can do is you draw your picture here. So side C is 30. It's longer than side B that was 20. And those are the numbers we were given. So when we draw the missing side, this is going to tell us we have an acute angle here, and there is no obtuse angle. So this means we can stick with that 41 degrees. So when you draw the picture of the triangle, that's going to help. It'll help sort of remove any ambiguous cases. What was unusual about the last example there, where we had the two different angles for B, the triangle, and we couldn't decide on which version. Had to work with both. But this one, though, when we draw the triangle, longer side, shorter side, the line that we have to draw here is going to create an acute angle. There's no other version of this triangle where C is 30 and B is 20. So that's why we're not going to worry about two angles here. All right. So we've got our sides. A, B, C, great. The angles, A, B, we still need C. Step 3. So again, A plus B plus C is 180 degrees. Or 60 degrees plus 41 degrees plus C is 180. Or 101 degrees plus C is 180. Or subtract 100 from both sides, C is 79 degrees. And that's going to be our answer. So any questions about that? So again, when you use law of cosines, now for a side angle side, we're not done with law of cosines. It also has a different version that we need to consider, the side triangle. But for side angle side, we've got those three steps. Law of cosines to find the missing side. Law of sines to find the missing angle that's across from the shorter of the two given sides, two that they gave us. And then once we've found that angle, we use the other angle we're given and the fact that all the angles add up to 180 degrees to solve for that one missing angle. And then we're good. We solve the triangle. We know the angles and we know the sides. So the last thing to look at, let's see here, it's the side. So the example I'm doing, you can follow it, it's page 747. So let's say we have a triangle like this. In fact, let me introduce this a little differently. We have a side triangle. Now, we're told that A, let's see, they gave us A is 6, B is 9, C is 4. And they also say round the angle measures to the nearest degree. Oh, so be it. So if we've got our triangle, and I'll be honest, I draw triangles kind of haphazardly. So I'll say I'll draw a triangle like this. Okay. So A across is 6, B is 9, and C is 4. Now that honestly doesn't look right. So this has got to be shorter than this. This is going to be longer than the other two. So I'm just going to redraw it. So make sure this one's longer, this one's shorter, and this one's like that. So shortest, next shortest, least shortest, or longest, shortest, one in the middle. Least shortest, you have to ask somebody from the English department about that. Anyway, moving on. So A is going to be 6, B is 9, C is 4. So using the sides here, I can give like a rough sketch and like, ooh, that doesn't look quite right. Adjust things accordingly. So this is all right. We've got everything here except the angles. So here's a situation where we have the sides of the triangle, just no angles. So let's solve for the angles. Now, we're going to solve using, let's see, side B first. So this is what we've got. B squared equals A squared plus C squared minus 2AC times the cosine B. Now again, because we now have an accurate triangle, because again, you sketch it, you're not sure, don't worry. You know, just get the information on there and then adjust it accordingly. But this is what we should expect. Acute, obtuse angle. We're watching for B to be obtuse. So B squared, well, that's going to be 9 squared. A squared is 6 squared. This will be 4 squared minus 2 times 6 times 4 times the cosine. Angle B. Double check, make sure I've done my substitutions correctly. Looks okay. And then we have a B and a C. Okay, we're looking good. Just watching the time. So you might go a little over time. So 81 is 36 plus 16 minus 2 times 6 times 4 is 48. Cosine of b. So 36 plus 16, 42, 52 minus 48 cosine of b. Let's see, subtract 52 from both sides. Let's see, we get 30, 29. Double check that real quick. Yeah. So divide both sides by negative 48. We get negative 29 over 48 is the cosine of b. Let me check my arithmetic. Yeah. All right, so we're looking good. So cosine inverse. Let's see what we get. So we get 127 degrees, or approximately 127 degrees. It's 127.16888.997, which should round to 127. Let's see here, did they do that? Yes, they did. So we've got that. Now in the text, they took the positive. Let me see here. Let me double check something. So your cosine inverse should allow, yeah, you should be okay to have negative values there. So a little why they're doing that. If you did 29 over 48, which is what they do in the text, you'll get 53. Now, the problem with 53, though, is again, 53 is an acute angle. So what we need to make sure, yes, I'm not sure why. Let me think about why they did that. I just use cosine inverse of negative 29 over 48, and I get the answer. Now, it's going to work out because cosine inverse gives us angles from 0 to pi. So that means it'll give us acute and obtuse angles. And we need an obtuse angle here. And it turns out we get it if we take the cosine inverse. So now what you could do, if you're going to sort of, in a sense, play it safe, if you will, let's see here, 28 over 28. I might need to get back to you on that. I want to see why they've chosen to do that. Yeah, it looks like they don't give an explanation as to why. They do have a note in the textbook saying that you can do this and it's okay. And again, the reason is cosine inverse will give you angles from 0 to pi or 0 to 100 degrees. So it will give you that obtuse angle. So all right, we've got B's 127. So we need to get at least one more angle, and then we can use the fact that they add up to 180 to find the missing angle. So to find the last angle, we can use the law of sines again. So you can think of this as our step 1 law of cosines. Now, again, for the law of sines, and they don't really say that you have to use search for one angle or the other. You can play it safe, go with the angle across from the shorter side, and that just is a good habit for these types of problems. So I'd recommend doing that. So again, I'd say use the law of sines to find the angle across from the shorter side, just so you get into that habit. And then what we'll do for step 3. Again, last. So we've done step 1. Oh, not find a side, pardon me, make this change on your notes to find an angle. So what's different when we have a side is we're using the law of cosines to find an angle instead of a side. But then everything else, I'd say stick with it, including step 2, just so you get in the habit of doing it. So let's do that, step 2. So let's go C. Oh, we can't go. Oh, yeah, we can. Sine of C equals. And then, let's see, we don't have A. We got to go with B. So B over sine of B, because we don't have angle A. So we don't have angle C, but we do know side C. We know side B. We know angle B. Let's go for this. We can cross multiply. So 4 sine of 127 equals 9 sine of C. Divide by 9. So what we're going to get, 4 times sine of 127 divided by 9. So approximately 0.432280030, which is about sine of C. Now again, look at C. C is going to be an acute angle. So we're not going to worry about finding that obtuse angle. We're just going to be dealing with an acute angle. So sine inverse. So what's that going to turn out to be? Let's see. Answer. So this comes out to approximately 25.6 degrees, which they should round to 26. Let me see, hold on. Make sure I didn't make a miscalculation here. Double check, make sure I didn't make a miscalculation. Pardon me 1 second. Okay. Oh, sorry, I see what I did wrong. There we go. Sorry about that. This is 0.354949116. So I have to make a confession. My calculator is in radians mode. Make sure yours is in degree mode. But at the time, since I've used this calculator, I can't get it going to degree mode. So I'm stuck in radians. So I got to multiply my degrees by pi over 180. If I forget to do it, I get the wrong answer. So what I'm going to need to do is sit down and try to remember how to get it in degree mode. Make sure your calculator is in degree mode. It'll make your life much easier. So very sorry about that. So do as I say, not as I do. But if you are stuck in radians mode, multiply your degrees by pi over 180, and that'll let the calculation come out okay. So sine inverse. And then when you do your sine inverse, if you're stuck in radians mode, don't forget to multiply by 180 divided by pi again, because it'll give you an answer in radians. So that's better. So it's 20.79, or approximately 21 degrees. So finally, A plus B plus C equals 180. We don't know A, so this is step 3. A plus B is going to be 127. 21 degrees for C. Or A plus 148 degrees is 180. Subtract 148 from both sides. We'll get A. Really approximate is 32 degrees. I'm pretty sure in your text they're going to say that you're going to have a hard equal sign there. So now we solve for that triangle. Any questions about that? Now I know we're way over time, so I'm just going to do one last thing. I just want to point out the area of formula. It's Heron's formula for the area of a triangle. Just so we conclude 7.2, so it's done. And that means we don't have a piece of it like 7.1 sort of waiting to be gone over. So the formula is this. This is Heron's formula. So what we have are the sides of a triangle, A, B, and C. And then this thing S. Now S has a particular. It's 1/2 A plus B plus C. And this is for triangle sides. A, B, C. So for the area formula here, we'll just do an example out of the text real quick. We're just going to plug things in stages. So, for example, let's say A is 12, B is 16, and C is 24. So the first thing you're going to want to do is compute S. S is 1/2 A plus B plus C, or 1/2 12 plus 16 plus 24, or 1/2 of 52 or 26. So we find out that S is going to be 26. Now that we have S, now we can get the area. So you got S always subtracting something, and get an extra S there. And let's see, A was 12. B was 16. And C was 24. So this will be 14 times 10 times 2 on the square root of 26 times, let's see, 140, 280, or 7,280. That's approximately 85. And that's it. So that's section 7.2. So you don't have those due until the 10th. We've done section 7.3 already. So what we'll be looking at next is 7.4. I'll do a brief review on what the polar coordinates were, and then we'll start graphing these things in 7.4. And you will see graphing of polar coordinates again. It will come back in Calculus 3. So any questions, let me know. Other than that, have a wonderful day, and I'll post this in a little bit.